Behind every search result, video recommendation, and AI conversation lies an invisible network that powers the digital world. This network is not made of wires or satellites alone. It is a vast, interconnected infrastructure of supercomputers, custom chips, and data centers that operate silently across every continent. When billions of people access artificial intelligence every single day, almost none of them realize what infrastructure makes that possible. They do not know about the competition raging between technology giants to build the fastest, most efficient computing systems on Earth. They do not understand that what they think of as the cloud is actually a physical reality made of metal, silicon, and electricity. This is the hidden AI network, and it is reshaping global technology in ways most people never see. Understanding how it works reveals the future of our digital civilization, the trillion-dollar race for computing power. In 2025, the world entered an unprecedented era of artificial intelligence investment. Amazon committed over $100 billion to data center expansion. Microsoft allocated $80 billion to cloud infrastructure. Google announced up to $185 billion in capital spending for 2026. Meta committed $65 billion to AI infrastructure development. This is not competition between companies. This is an arms race for the fundamental machinery that powers artificial intelligence itself. The scale is staggering. Global spending on AI infrastructure hardware reached $82 billion in just the second quarter of 2025, representing a 166% increase from the previous year. Projections suggest that AI infrastructure spending will reach $758 billion annually by 2029. This represents a shift in how the global economy allocates resources. Traditional industries are being reshaped as capital flows toward computing infrastructure rather than physical production. The hyperscalers, Amazon, Microsoft, Google, Meta, and their competitors now account for 2/3 of global cloud infrastructure spending. Together, they plan to add approximately $2 trillion in AI-related assets to their balance sheets by 2030. This investment creates barriers that smaller companies cannot overcome. The infrastructure gap becomes a competitive moat. Those who build faster win. The physical backbone beneath the cloud AI infrastructure is not abstract. It is concrete, steel, power cables, and advanced cooling systems. Data centers have become the factories of the artificial intelligence age. A single AI data center can span 500,000 square feet, consuming as much power as a small city. These facilities operate around the clock, maintaining server temperatures within microseconds of optimal parameters. The Stargate Initiative, $500 billion private sector project led by OpenAI, SoftBank, and Oracle, plans to construct 20 massive data centers in Texas alone, each one an architectural and engineering marvel designed to squeeze maximum computational density into available space. These facilities require specialized hardware. Tensor processing units, or TPUs, are custom chips designed specifically for artificial intelligence workloads. Graphics processing units, or GPUs, from companies like NVIDIA, train models millions of times faster than traditional processors. Google's latest TPUs can train models in days instead of months, compressing research cycles and enabling faster iteration. Companies like Tesla are building custom chips at unprecedented scales. Tesla spent $1 billion on AI infrastructure in a single quarter and plans to expand capacity to 85,000 H100 GPUs for training autonomous driving systems. Elon Musk proposed using idle Tesla vehicles worldwide as a distributed computing network, theoretically adding 100 gigawatts of inference compute when cars are parked in driveways and parking lots globally. The networking infrastructure binding these systems together is equally sophisticated and critical. Data must flow between servers with minimal latency, requiring specialized network architectures. High-speed interconnects handling 400 gigabit per second signaling are now standard in modern data centers. A single error in networking architecture can reduce computational efficiency by 10% or more, translating to millions of dollars in lost productivity. Engineers design these systems at the edge of what physics allows, pushing against fundamental limitations. Power consumption has become the primary limiting factor preventing faster expansion. AI data centers can consume 120 kilowatts per single rack. Traditional data centers consume 1/10 of that power density. The world must generate unprecedented amounts of electricity just to power these systems. Companies are building strategic partnerships with renewable energy providers. Google announced major partnerships with clean energy companies across Europe, the United States, and emerging markets, securing commitments for carbon-free electricity. Amazon is investing billions in grid expansion and renewable energy infrastructure to support its rapidly expanding data center footprint across multiple continents. The innovation cycle accelerating faster. These infrastructure investments drive a feedback loop. More computing power enables training larger models. Larger models solve harder problems, creating more demand for AI services. Demand drives revenue, funding further infrastructure expansion. Each cycle completes faster than the last. Google DeepMind demonstrated this with Gemini models, processing nearly a quadrillion tokens per month, compared to 480 trillion tokens per month, just months earlier. That represents 2 times growth in processing demand in mere weeks. AI accelerator consumption grew 15 times in the last 24 months. Storage demand grew 37 times. Companies are beginning to deploy AI at the edge, bringing inference closer to data rather than centralizing everything in massive data centers. With Google DeepMind and robotics company Agile Robots, industrial AI systems now operate in factories and warehouses. These edge deployments create feedback loops between physical systems and central training clusters. Data flows from manufacturing facilities back to central data centers for model retraining, then updated models redeployed to the edge. This cycle creates continuous demand for infrastructure at multiple tiers, strategic competition, and national security implications. Nations now recognize AI infrastructure as strategic assets that determine technological dominance and economic power. The United States is accelerating AI infrastructure deployment domestically to reduce reliance on international suppliers and maintain technological advantage. The Trump administration positioned AI as a strategic national priority, lowering regulatory barriers for infrastructure development and fast-tracking approvals for data center construction. Federal agencies are investing $50 billion in AI infrastructure supporting classified and national security workloads, recognizing that advanced computation is now essential for defense capabilities. Europe announced plans matching American ambition in scale and urgency. France committed $112 billion to AI and cloud infrastructure, positioning itself as a continental computing hub capable of rivaling American capabilities. Germany announced 5.5 billion euros in expansion investments through 2029, creating thousands of jobs while building local technological capacity. Belgium pledged $5.8 billion to expand its AI data center footprint, recognizing that missing the infrastructure race means losing economic relevance. Europe recognizes that falling behind in infrastructure means losing technological sovereignty and becoming dependent on American or Chinese computing platforms. China continues expanding computing capacity at scales that challenge Western estimates. The opacity surrounding China's AI infrastructure makes precise measurement impossible, but American intelligence agencies assess that Chinese computing capacity rivals Western capabilities in many domains, including artificial intelligence training and deployment. The global AI arms race is not only economic competition, it is fundamentally geopolitical, with implications for which nations lead technological innovation and maintain economic influence in coming decades. The human dimension hidden within the machines. These massive investments create economic ripples. Amazon's Pennsylvania investment alone will add 1,250 permanent jobs, with thousands more in construction and supply chain roles. Data center construction has become one of the fastest growing sectors in the American economy. Entire regions are being reshaped as infrastructure investments anchor high-skilled job creation. But this growth masks underlying challenges. More than half of organizations report difficulties throughout their technology stacks in compute, storage, networking, data management, and availability. The infrastructure exists, but expertise to use it effectively remains scarce. Companies report struggling to acquire specialized talent for AI infrastructure operations. Cybersecurity vulnerabilities are intensifying. 55% of organizations